Well, good morning, everyone. Thank you very much for joining us at the State of the OpenCon 2023. We're here to talk to you about green software principles and embedding carbon awareness into your applications. I'm Dan.
And I'm Szymon. Nice to meet you all.
We work for Avanade, which is a member organization of the Green Software Foundation, which we also sometimes call GSF. Well, thank you for being here.
Yeah.
All right. So the reason we're here today is to make sure that you understand the concepts behind carbon awareness so that you are more likely to use it and understand bring this to your businesses or to your personal projects. So we'll start with the foundations, and we'll make sure that this basically helps you to understand how to use the SDK going forward. So just a quick show of hands. If you've heard of green software engineering before. Okay, cool. Most of the room. And what about GSF? Have you heard of the Green Software Foundation before? Okay, a few of you as well. So the Green Software Foundation is a non-profit organization dedicated to promoting environmentally sustainable practices in the software industry. So it works to educate software professionals about the impact of their work on the environment and to encourage the development of sustainable software principles and practices through research, training, and advocacy, such as events like here today. So the goal of the GSF is to reduce the carbon footprint of the software industry and help create a more sustainable environment for us all. Yeah, sorry, I was supposed to be on that slide. So when we talk about reducing the carbon footprint and therefore greenhouse gases emissions, we think about the greenhouse gas protocol, which is split into three scopes. The three scopes are, the first one is around direct emissions, which you could think as, having a fleet of vehicles. The most common example is having a fleet of vehicles and basically truck drivers switching on the engine and basically burning oil and releasing gas into the atmosphere, carbon into the atmosphere, or carbon dioxide into the atmosphere. The second one is indirect emissions from electricity purchases or where the electricity is being produced, so mainly like power plants, etc. And finally, the third one is indirect emissions from downstream and upstream activities, such as the supply chain, using delivery services for your business, etc., etc. So to dive deeper into the greenhouse principles, I'm going to hand over to Szymon.
All right, thanks, Dan. So the next few slides will cover basically the core ideas behind building greener software and more sustainable software, which we in GSF, so Green Software Foundation, refer to as green software principles. There are three core ways in which we can improve our carbon footprint of our software. The first one is around energy efficiency, which in very simple terms boils down to consuming the least amount of electricity as possible. The second one is on hardware efficiency, so using the least amount of embodied carbon in our software. And the last one is on carbon awareness, so doing less when the electricity is dirty and doing more when it's clean. We'll dive a little bit more deeper into the first two next slides, and then Dan will introduce in much more detail carbon awareness later on. So carbon and energy efficiency. Carbon efficiency is about emitting the least amount of carbon as possible. Why is that actually? Why is it important to us? Beforehand, we mentioned the greenhouse gas protocol, which is about the emissions and the impact of greenhouse gases in general, not just carbon dioxide. But in the software industry, we want to boil it down to as little as possible. We want to keep it standard, so we try to introduce something known as carbon dioxide equivalent. So that way, every single gas greenhouse gas can be recalculated to CO2 equivalent. And when we talk about emissions, we just use carbon dioxide equivalent or carbon for short. So when you hear us saying carbon, think of this. And then energy efficiency, so that builds up on top of carbon efficiency. All electricity comes from different sources. Some of it is from burning oil, some of it is from burning coal, others are from gas, or even more sustainable sources. So when we use that electricity, by extension, we also emit carbon somehow the energy has to be produced. And then how can we actually minimize that energy usage? One of those examples is by using energy proportionality. So it's a very simple thing. If you use a lot of computers at low utilization, each computer has some base threshold of energy they use. So if you use fewer computers at high utilization, you will use less electricity and a bit less carbon. So when you can do that, that's one way to do it. And then here we go through the next three principles. So the first one is hardware efficiency. So what we mentioned, use the least amount of embodied carbon possible. What is actually embodied carbon? Like some of you may wonder, it is the amount of carbon that is being released during the production of devices and then at the end of its lifespan, like destruction of them, right? So how can we reduce the impact of that? One way of doing so is to maximize the lifespan of the devices, so try to reuse them, have circular market of parts, and continue their usage beyond their original lifespan. The next one is measurement. Core idea here is what you can't measure, you can't improve. Beforehand, Dan mentioned greenhouse gas protocol. That's why one way of measuring the total gas emissions of an industry, of a system. There's also something known, which is being developed by the Green Software Foundation, known as Software Carbon Intensity Specification. It is actually now, as of COP27, an IEEE standard, if I'm not mistaken, and that will help you measure the rate of carbon emissions of your software. So it's another way to help you measure that. And then the last thing is climate commitments. So understanding what are the actual mechanisms behind reducing carbon emissions. The two main ones, as you might see on this graph, is it splits into offsetting and elimination, right? Offsetting is the notion of paying someone else or asking someone to, either improve what we have done, so take out the carbon we've emitted from the atmosphere, or pay someone to just not emit the carbon. And then the other one is to reduce the amount of carbon we emit or stop it at all. As you might think, obviously we are aiming to do the second one as much as possible, because that's where we totally eliminate it. That's our goal. And the next section, we'll cover carbon awareness, so the last principle which we will want to focus on today a bit more. And I'll hand over to you, Dan, to explain that in more detail.
Thank you, Szymon. So not electricity comes from the same energy sources. So we have some of the electricity that's produced from renewables sources, such as wind, hydroelectric, solar. And then we've got some other sources which are known to be less clean, such as fossil fuels. And even within the fossil fuels, we've got gas, which is considered cleaner than burning coal to produce electricity. So what that means is that we have energy sources that are generating different levels of carbon emissions, and what we basically call carbon awareness is the ability to use more energy when the energy is coming from low intensity carbon emissions generation, and less electricity when more of the energy is coming from fossil fuels. So, a few concepts we want to introduce. The first one is carbon intensity, because the point here is that how do we measure that we are using electricity that's coming from lower carbon emissions sources is by being able to measure them. And so there's a unit which we call carbon intensity, which is measured in grams of carbon per kilowatt hour. And the idea is that that helps us compare different time the energy to basically understand if it's cleaner at that time or not. So for example, on that graph here, we can see that on the left, the energy is looking a lot cleaner, and the proportion on it is smaller for fossil fuel and bigger for renewables. Clearly, there was potentially a lot more wind and solar and sun at the time. And then on the right-hand side, we've got something that's a lot less clean with 350 grams per kilowatt hour of carbon per kilowatt hour. And in there, we can see the proportion of fossil fuels is a lot bigger. I think we represent of coal and gas. Now, if we take this to an extreme, if today you were to connect to a wind farm, your carbon intensity would be 0. Right now, we know that it's not necessarily possible for everyone to do that, or for anyone for that matter. What we all familiar with and what we all use is the national grid, which the utility providers manage. And they have to basically manage the demand, the demand and the supply and demand. Sorry, that's what I was looking for. And the idea is that we can't control how quickly the wind is going to blow or how much sun there's going to be at any point in time. But we can control how much coal we're going to be burning to produce electricity that we need. And so if we think about the national grid and how the needs of the country are necessary at different times, I think you all remember on the news that there was this thing about like not using the electricity at the peak hour of the day. I think it was between 5 and 4. So we know that the grid has a limit, and we need to be able to balance the use of the electricity or the demand to make sure that everything's fine. So that means that the fossil fuel energy that we produce is something that we require a minimum of. And so that's why when we look at the measurements of carbon intensity of different countries, that intensity is never really 0. It's always a bit of something. So here we've got some examples of that. So let's get into then the kind of like 3 concepts that you can use to apply carbon awareness. The first one is around time shifting. So what that means is that if you look at this graph, the blue line is the carbon intensity at different times of the day. I think here it spans between midnight and 8 a.m. And you can see that the intensity starts at a very high number. Here is 400. It goes all the way down to, let's say, 20, and then goes back up at different times. But if we were to shift our workload by an hour, we can see that the intensity of our carbon is significantly lowered. We've got the same that applies for location shifting. So it's the ability to run our workload in a different location. For lots of different reasons. I think here we're showing Spain, which is a country that I always think of when I'm thinking about sun. And so we can expect that the solar production is a lot better there than it might be somewhere in the north of Canada. And that's obviously, this is just for illustration purposes here. And obviously it will depend on the time of the day. I don't expect Spain to have any sun in the night. But you get the concept of being able to move the workload depending on the time of the day. The final one is called demand shaping. And demand shaping is about using more of the electricity when we know it's cleaner, basically doing more of the work. I'll take a very simple example that we apply at home since we've installed solar panels a few months ago. And I think my wife will probably laugh at that concept because it kind of like is on our mind quite a lot, is that as soon as the sun is out and we've covered the workload of the house, the current load of the house, and we've potentially charged the battery, then we're thinking, okay, well, now we've got extra electricity that's going to be wasted. Why don't we just, run an extra wash or, do things that we would have done later at a time when the electricity wouldn't have been as clean that we can do now. So now we've introduced those concepts. Let's get into the slightly more technical part with the SDK with Szymon. Szymon, back to you.
Thank you very much, Dan. So now that we know what carbon awareness is, let's look into a tool developed by the Green Software Foundation known as the Carbon-Aware SDK, which actually had its first release during COP27, if I'm not mistaken. What actually is a Carbon-Aware SDK and why do we need it? Hopefully, you kind of understand the need for it by now, looking at those previous slides, but being mindful of time, I will cover some of those points mentioned here. So first of all, it can allow you to create software systems in a consistent and standardized way. So by using an open source tool that might hopefully become a standard for building carbon-aware applications. It will allow you to, for example, run hypothetical models and go and ask yourself, go ask your customer, your client, why would it be, for example, worth to move our job, our machine learning training or something else to a different time or different location by looking, for example, at data 50 days ago and seeing how it might have changed if we moved it 3 hours earlier or 3 hours later. How does the Carbon-Aware SDK look like? If you look at the graph on the diagram on the left, it sits somewhere between your applications, which might be in the cloud, might be locally, and the data providers. And the data providers we are using at the moment is, for example, the service called WattTime, electricity maps, or it might even be your own data modified by you or by your enterprise that you want to include there. And this can be deployed as an API sitting and accessible by all of your applications within your organization, or can be a CLI, which you just call in, I don't know, a GitHub action or just by yourself from the command line. And a few other points here is it is you can centralize your carbon intelligence in a single spot and provide capability everywhere. So instead of re-implementing this into every single application, you can have a single spot where you put the API and all your applications call it from there. Then if we can switch over to my laptop screen, which I'll just turn on now for just a quick second. I'm mindful of time, so I don't want to spend too long on this, but I just want to show how this can be demoed in a Jupyter notebook using a Python library generated with OpenAPI generator. This is like an example of how you can use this SDK, this tool, to either like build a business case and just try to convince someone, or just look at yourself why doing a time shift or a location shift of your job, of some of your applications might be worth considering. This graph, as you can see here, is actually from data collected back in June and August 2022. This is an example of a time shift done in the West Central Azure region from 8:55 p.m. to 11:55 p.m. The blue line is 11:55, and the y-axis is the carbon intensity. As you can see, when we were to move that in that time period, the drop in carbon intensity is quite significant here. And if I scroll down, this, by the way, is available on GitHub, currently in one of the pull requests still for the Carbon-Aware SDK, but you will be able to find it if you want to see an example of applying this. And okay, there's the other graph. Let me just find the big one. And here is an example of a location shift. So looking at a few regions globally, namely West Central US, West US 3, and France Central, all at the same time on a 55-day period. As you can see, a location shift here, if our job is not location bound, can save quite a bit of carbon as well. I can even find an exact value. That's 51.76% carbon saved, actually. If we can switch back to the slides, please.
I like that because France is winning in this case again.
Yeah. So hopefully not everyone will switch over to France at the same time, but you know, it is a good option at the moment. And now just going quickly through how you can apply this in a Kubernetes environment. Kubernetes is as you might know, an easily scalable environment for distributed applications. This is a monthly invoicing system application example where you have let me just move up this screen. On the right-hand side at the bottom, you have an application that produces some invoices. they stored in a Redis cache, and then at the end, they're being distributed to some applications which process them. And the idea here is we have at the top a carbon-aware SDK API deployed, which we set to poll every once in a while. We set a certain carbon intensity threshold below which, when the carbon intensity falls, we scale up. And as you can see, we have now 3 pods deployed. We can deploy multiple applications, process those invoices. And when the carbon intensity goes above that, we decide to scale down to 0 and just build up the queue. Yep, so that's a simple example how you can use it. And to just summarize on that, what actually the SDK addresses is the first point, a unified approach. This is an open source project, so all industries working on this, using this tool, can contribute towards it and can build to the single standard tool instead of every single team developing it on themselves, right? We can have a single tool for people to use and contribute towards. And the other thing is people coming from different industries, when everyone uses this tool and the same data sources, it's easier for them to compare the carbon intensities of those regions and decide if this is a good decision to make or not, and talk to each other, bring this discussion forward, not just keep it like as a buzzword. The next thing is reporting and forecasting. So we are able to forecast our decisions in the future and how our deployment might do by looking at future data, how the carbon intensity might change over time, and decide if we want to move this around or not. And the last one is high integrity and auditability. Using verified data sources, we can make sure we are not greenwashing, and also by being able to look back at past data, we can see why certain decisions were made, why we decided to actually do that time shift. If someone asked later on, why did you actually move from that region to another one? You can show them, hey, this is clearly the data I was looking at that moment. That is why. And that's all in that area. So I'll now hand over to Dan for a wrap-up.
Thank you very much. So today we've covered the green software principles and the carbon-aware SDK, and hopefully you can see how it can play a significant role in reducing the carbon footprint in the software industry. So by all being mindful of the energy consumption of our software, we can make a difference in the fight against climate change. So now it basically is up to us to really take action and do something about it, because small action by each one of us can have a big impact as a whole. Obviously, if you want to dig deeper into this, you know, what's next for all of us. If you want to basically dig deeper into the principles, we invite you to go on learn.greensoftware.foundation. It's a website that has a lot more details about the different concepts we've introduced today, a few quizzes to help you do a bit of knowledge check, and at the end, an exam to give you a certification to help you advertise that you're aware of green software principles, engineering principles. And on the more practical side, and obviously, you know, the green software principles again are not necessarily just for technical people; it's for everyone, because, you know, as we said, it's a group effort. And finally, we've got the SDK, which is available on GitHub. Simply just put carbon-aware SDK GitHub, and you'll find it straight away. Or you can go through the Green Software Foundation website. We also want to take this opportunity to thank all of the people who have contributed to the project so far, and we hope that a lot of you will join us and contribute even further to this project. I think with that, that's all. Thank you very much all for your time. And do you have any questions for Szymon?
Thank you very much. Just before we go to questions, is our next speaker in the room? Luke?
Over there.
Oh, is he there already?
He's here.
Okay, great. If you're not already, could you go round to the side and get yourself mic'd up? Great. Yeah, so thank you so much. Do we have some questions? Yes, I see a hand here already.
This is awesome. So far, the best way people have been able to estimate their carbon impact has been cloud cost. Is there a plan to integrate with FinOps or things like that? Because of course, I think boards will be motivated, sure, by the green, blah, 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 but right now I think it's about financial. And this year it's gonna be about money. Is there a plan to integrate with FinOps or something so there's a connection and a visible understanding of the cloud cost versus the carbon cost?
So I guess I'll take that question. There's a white paper that just came out about the contribution of UBS into this project. So they've basically been the first contributor to the Carbon Aware SDK. So I think that's the FinOps area that you're talking about. And yes, it's about planning and better scheduling jobs that are going to use a lot of resource at a very specific time of the day. So I guess it's in motion, but I don't know if that's necessarily a way of doing this like for everyone. I think the idea is that we put the tools out there together, and then your engineering teams or your DevOps teams, etc., can basically leverage this. I think it's also a good occasion to kind of like plug in the CI/CD pipeline working group, which basically intends to leverage the Carbon Aware SDK to create schedulers for your work. I hope that answers your question. Do you have anything to add?
No, that's good.
Cool.
More questions? Anyone? I have a question, which is, what's the kind of uptake so far, and what's the impact been so far?
So there have actually the member companies of Green Software Foundation, so like UBS, Microsoft, and a few others that I don't remember off the top of my head. I know they already use it with client solutions, the Carbon Aware SDK. You might have seen already things like Windows 11 becoming Carbon Aware, Xbox Update becoming Carbon Aware. This isn't actually, as far as I know, using our tool yet. But I know in client areas, this is already being used by Microsoft and UBS.
Yeah.
Amazing.
Sorry, just if I can add, the main point here being that everybody can use different approaches, but the idea is that if you use the Carbon Aware SDK, we can all use the same playing field and basically build something together to improve it for everyone at the same time.
Any last questions? Super important stuff, so thank you so much. Brilliant.
Thank you very much. Thank you, everyone.
Yeah.